Good morning, good afternoon, good evening, wherever you may be hailing from. This is Red Hat Enterprise Linux Presents. I'm your host, Eric the IT Guy Hendricks, and joining me every episode is the one and only Mr. Brian Smith. Welcome back.
Hey, Eric. How's it going today?
I have mixed feelings. I feel like I've been productive, yet not productive at all, if that makes any sense.
Yeah, some days it just seems like you're just, looking through email all day and you didn't really get anything done, huh?
That's what it feels like. But truth be told, I've been saving up my energy. I've been hanging out because we've got an exciting episode today. We talk about a lot of different concepts on the show. We talk about things like automation. We talk about having identical systems. We talk about automation. We talk about Ansible. We talk about a lot of these things at concept, but we haven't really shown you the entire picture. And so we've got actually three guests today because this is a huge topic. So we couldn't do it with one or two, so we needed three. So full house today. But I'm excited because we're going to kind of take all of this and package it up and show what it looks like to use a lot more than just RHEL, a lot more than just Linux on the command line, in order to manage systems, in order to deploy workloads. And the demo gods willing, will actually deploy a workload on Azure live on the show. So I think we should bring in our guests. What do you think?
Yeah, sounds good.
Gentlemen, I think this is tied for the largest episode of RHEL Presents ever. So why don't we go across the board here and do some introductions? Martin, you want to kick us off?
Yeah, sure. Hi, everybody. My name is Martin Jackson. I'm a software engineer at Red Hat on the Validated Patterns team, and happy to be here.
Welcome, Martin. Mr. Paul Armstrong, you're next.
Hi, folks. My name is Paul Armstrong. I'm a principal technical specialist for RHEL. I handle all of the RHEL business in Canada.
All the business. And I take I understand you're traveling this week.
I am traveling. I'm in our nation's capital, Ottawa, for Summit Connect.
Awesome. Just real quick, 30 seconds. What is Summit Connect and why should people try and find one near them?
So Summit Connect is our opportunity for Red Hatters to go out and reach out to those customers that weren't able to make it to Summit this year. We understand that everybody's got travel restrictions, and sometimes it's difficult to, for Canadians especially, to get out of the country to go to different events and get funding for that. So we're taking the best of Summit to our customers and delivering it in a city near you where you can go and experience the talks, see the demonstrations, and work through some of the hands-on labs to work with some of the things that we've done at Summit.
As much as I love going to Summit, I got to say the Summit Connects are really nice because it's a little bit more intimate of a setting. You get a little bit more one-on-one time with some of the experts. I know each of the major BUs from RHEL to OpenShift and Ansible send experts and leaders to go and be present at these events. So there's always a chance to run into somebody and get some really good questions asked. So if you missed Red Hat Summit, or maybe you just can't get enough of it, definitely check out Summit Connects and see if there's one near you. Now, Brian, that was a completely unexpected turn in our agenda, but hey, free PSA for Summit Connects. Last but not least, Mr. Mike Savage.
Yes, hello. Mike Savage here, Chief Architect with our Field CTO organization. I primarily work with our ecosystem partners. That's pretty much every type of partner across the board. Today we'll be talking about one of our cloud partners, Microsoft Azure. Really happy to be here.
Very cool. Well, we have a lot to cover today. But there's a lot of different terms that some people might not be familiar with. So can we start just by covering some of the terms we'll be referring to today? Like, what is infrastructure as code?
I'll take that one.
About to volunteer somebody.
What we want to do is visualize an architecture and then define it via code, configuration, etc., so that then when we were to use automation to deploy that configuration, it actually deploys in the manner in which we define it within source code.
Yeah, I love that. It's codifying, it's self-documenting, it's something that's easy to automate. Um, in fact, completely by happenstance, I'm reading the book on the subject, Infrastructure as Code by, I think it's Keith Morris. Yeah, Keith Morris. It's been an interesting read talking about using pipelines and CI/CD concepts to build out your infrastructure. So for those of you sysadmins out there who don't think you're a developer, I like to market myself as a YAML engineer nowadays. But infrastructure as code is a really effective means of ensuring that you don't have a lot of drift or you don't have a lot of misconfiguration. Now, when we use a concept like infrastructure as code, or IAC as it's sometimes referred to, we get into a conversation about SOE, or standard operating environment. Um, so, Paul, you want to talk a little bit about what SOE is?
Sure. SOE stands for Standard Operating Environment. This is not a new concept at Red Hat. Back probably 2013, 2014, we published a series of documents that described what Red Hat refers to as a standard operating environment. And it's closely associated with how we deliver content and build systems using tools like Red Hat Satellite. And the notion is to take start with a defined set of content for the operating system and tailor that for our organization and deliver that as, excuse me, a content view, if you will, in Satellite. And then as we go along, we can layer on other, call it configurations for different kinds of applications that we deploy, and we can create composite content views to define those particular environments. We couple those with things like the partition table definitions, the templates of what kinds of configuration files we're going to set up, etc. And that becomes our standard operating environment. Really, when we take that to the next step and we say, okay, we're going to marry a standard operating environment with infrastructure as code, now we get into being able to define that standard operating environment and all the stuff around it in YAML.
Very cool. Very cool. And then Martin, I think the last term we really need to define before we get into more details is, what is the definition of GitOps?
Yeah, sure. GitOps is a movement that really started in the Kubernetes world. And as a, we all like to talk about ourselves as YAML engineers this way in these days. And, a lot of what we do in terms of managing infrastructure is managing YAML files. But what GitOps has allowed is the ability to really define large chunks of the way that things work and the environments that we deploy to and the system images that we work with, where workloads run in YAML terms. Now, formally speaking, GitOps is most at home in the world of Kubernetes, but we at Red Hat believe very strongly that GitOps also applies to the world of RHEL and Ansible as well. In fact, my main engineering team that I work on, the validated patterns team, started out as an OpenShift Kubernetes focused team, but we've always been looking for opportunities to expand the reach of GitOps into the RHEL and Ansible world. And a lot of the engineering work that I've done, and honestly, the way that I met Paul and Mike here, involved our expanding the idea of GitOps into the world of RHEL and Ansible Satellite IDM and all of those other wonderful things that we provide in the RHEL ecosystem. So formally speaking, GitOps is based on 4 principles. The first principle is that a GitOps configuration must be declarative. It must describe the state that you're trying to achieve with your infrastructure as code, and not be focused on the individual steps to get there. So We define which packages need to be installed. We don't specify the exact commands for how to install each package, for example. The second principle of GitOps is that it must be versioned and immutable. That means that a GitOps config is tied completely and inherently into a Git repository. And by advancing the timeline in the Git repository or rewinding the timeline in the Git repository, that should change how the deployment from that Git repository is done. So we move forward to proceed with the deployment. We move backward to undo the deployment conceptually. The third principle of GitOps is that it must be pulled automatically. So there must be an agent that is running that checks to see whether the Git repository has changed to tell whether there is GitOps work to be done. And the fourth principle of GitOps and the final principle of GitOps is that it must be continuously reconciled. So every once in a while, the GitOps agent runs and does work if it needs to, and doesn't do work if it doesn't need to. It's really important at this point to specify that to meet the GitOps definition, you need to be running Ansible automation platform. This can't be done with ordinary command line Ansible by itself, because ordinary command line Ansible, while it can be declarative and versioned and immutable, it cannot be pulled automatically and it cannot be continuously reconciled. That's what Ansible automation platform does for you in the GitOps definition and according to the rules of GitOps. And we're going to be really excited to be able to show you how that works in practice here.
Yeah, I think it's really important to keep in mind that what we're discussing today requires Ansible automation platform. And this is more or less a different beast than, say, Ansible core, which I'm surprised Brian hasn't said it yet, but is really driven for system roles, which kind of play into the SOE world, managing system roles. But Ansible automation platform, to really get this GitOps, is sort of a requirement. One other term I want to cover is validated patterns. Martin, you said you work on the validated patterns team. Why don't we define that real quick?
Yeah, sure. The standing on one foot definition of a validated pattern is that it is a reference architecture which is delivered as a software artifact. And all validated patterns are inherently GitOps artifacts. We have a site, validatedpatterns.io, where you can look at all of the different validated patterns that have been written. Each of them is downloadable and runnable. The idea with the validated pattern is that, historically with reference architectures, you get a description of what should be deployed in a reference architecture, but you don't necessarily get to actually see it running. What we do with validated patterns is we encode the reference architecture as a GitOps deliverable so that you can, if you have sufficient infrastructure, you can run those validated patterns yourself. You can use our framework that we use to develop these validated patterns. You can test and see the ones that are there. You can extend them. You can adapt them for your own purposes.
So we've got a bit of a cooking show for you today. So we're going to be jumping in and out of the demo, but what we wanted to do first was kind of define some of these terms, because we'll end up hearing them a few times. Of course, there's a lot of jokes about starting a drinking game during this episode. So if you're not catching this live, you're missing out. Definitely join us live when you can, and join in the chat. We also take questions out of the chat, so you never know what you might be missing if you don't catch us live. But Paul, you are our resident demonstration guru for the day. Hopefully you've made the appropriate sacrifices to the demo gods. And so why don't, since we are going to be jumping in and out of the demo, why don't you frame up what we're going to be seeing today?
Okay, great. So frame up what we're going to see today. What we're going to see is something actually, it's incredibly large. The original version of this project was something that Marty and Mike and I had started working on a few years ago. and we called it Red Hat Infrastructure Standard Builder. And there's several components to this. There is the notion that what we want to do is get to the nirvana of GitOps, as Marty has described. But in order to get there, we need to get a bunch of infrastructure up and running. So we actually wrote all the code to deploy Red Hat Identity Management, Red Hat Satellite, and Red Hat Ansible Automation Platform in basically any configuration in Ansible. So it goes from 0 to fully configured. And that means all
And image builder.
And image builder, yes. And actually Insights, the image builder on the cloud. And what it allows us to do is define in YAML what the definitions are of these systems, what their configurations are, and run these in an idempotent fashion. So that as you go and you update components or you update configuration around whether it's a set of users or pseudo rules or content views or Ansible templates, it actually just picks it up and puts it into the system. It's quite interesting. But then the goal is, well, what do you do with that infrastructure? And as we go along and we start talking about what are the processes that we want to automate for the customers? What do we want to make sure that we don't have to do every day so that we can focus on building out our environment and making sure it meets our business goals instead of doing all of the lights, keeping the lights on kind of work. So what we'll see today is one of the pipelines that gets created as part of this infrastructure as code. And what that pipeline does is it goes in and it automates Ansible Automation Platform. It creates a workflow, a series of templates, and then strings them out into a workflow template that actually drives Satellite and drives testing. So it will go and once we kick off the workflow, it'll go and update the errata end date for a number of filters for satellite content views. It'll publish those to the library. It will then promote those into the first lifecycle environment. It will go and deploy hosts wherever we want, whether that's on Azure or VMware or AWS, OpenStack, it doesn't matter. It'll go and deploy some test hosts. And then it goes through the process of saying, okay, I'm going to snapshot those so I know what they are before I did any work. And then I'm going to go and I'm going to deploy some applications. And then once I've deployed the applications, I'm going to run some deployment test scripts to ensure that those applications are deployed correctly. And if they are, then what I'm going to do is I'm going to promote that code to QA and then delete the snapshots. So that's kind of the demo that we'll see. And if you want, I can flip to the demo screen and we can take a look at that.
Yeah, let's dive on in.
Yeah, so as Marty was mentioning, we're trying to deal with GitOps, so infrastructure as code. This is one of the repositories that we use for building out the infrastructure. And as you can see, if you're familiar with Ansible, we define an inventory, and then for the hosts in the inventory, we can have a folder in our project that it defines the host vars for that particular host. We provide a subfolder that has that the FQDN of that particular target, and underneath that folder, we can put all of the YAML files that define the configuration. In this one, we've got, as an example, the satellite.example.ca host, and we describe in it all of the things that we can create. As an example, here are the activation keys that will get created, and we define a list of the activation keys, and we just, when we deploy the this YAML, the code will get launched, and it will drive this into the satellite server. And we have basically absolutely everything that you could, define for the environment, including things like the Ansible roles that we might want to include on the satellite versus on the Ansible Automation Platform server. It has every definition for all the global parameters that you would need for all of the templates that get deployed for satellite, as an example. It fully configures the environment. So this is what actually ends up building the entire infrastructure. And then once we do that, and it's fully deployed, one of the things that we'll see is this particular workflow. Let me just log in here. And here are the templates. And down here near the bottom, we have this particular workflow template. If I go and take a look at the visualizer, I'll zoom in on this a little bit, and we'll see basically what I had just described in that overview. In the environment here, we have a series of tasks. It starts off, and there's the first task is called publish content. It runs a playbook that will go out and look at satellite, and given the content views that we want to use, this goes and it uses some basic information that we provide in the system. And let me go back here, and I'll use another window here and show the content. If we look at the templates, as an example, in our published content, all we're providing in this is we're providing a number of basic variables. Do we want to ensure that it gets published? Whether or not the system says, oh, it's been published within 6 hours, I don't need to publish. But force publish will tell it, no, I want you to publish this now. Validate my satellite certs, make sure that I'm validating the certificates. This is for a system that's registered with a set of CAs. You can have it set to false if you're using self-signed certificates in your environment. And then we just list the content views. And we list the name of the errata by date filter that we're going to update as part of this. And then we list the composite content views that we're going to publish as well. That's what happens in the first one. And so this gets published to the library. In the second one, we're promoting that content to the first lifecycle environment that we're going to do. One of the most important things about this model is we're driving a series of workflows where we're testing everything before it goes into production. So we, and I think it was Mike that mentioned it, is what we're trying to do is we're trying to shift that discovery left so that we're further into earlier on in the development cycle or in the design cycle, we're encountering the errors that we might see because of configuration, and we're ensuring that we can understand them and get them fixed before someone tries to apply something to production. So this is promoting it to the development environment. On the back end, actually what you see is it's not really a dev per se. It's give me a current lifecycle environment that I have and what my target lifecycle environment is. So I can reuse this code just by changing the variables. It doesn't matter, kind of which environments that we're sending things to. And in fact, this target lifecycle environment, if we get into more complicated promotion scenarios, it can take a list. so that we can have multiple target lifecycle environments. And then in this one, we're actually creating some systems. The systems in our test environment don't have to exist. They don't have to be there all the time. They're ephemeral. And in the background, what we're doing is we're calling an Ansible task called create host from host group. And what it does is it talks to Red Hat Satellite and says, here's the 4 or 5 parameters that you need. Here's a fully qualified host name that I want you to give to the machine. Here's the host group that I want you to build it from. Here's the base of the system that I want to build the system on. And here's the compute resources that I want you to use. And the t-shirt size. And off it goes and it builds the box. It will build this particular role. It'll build anything. And it doesn't, whatever you've got defined as a compute resource on the satellite server, whether it's Azure, AWS, KVM, OpenStack, or even bare metal, it'll deploy that system. And based on the type of system, it will go off and it will figure out what kind of snapshot it needs, and it will create a snapshot of the system. And the last bit, what's going to go on is this particular workflow says, I have 3 different applications that I'm building from these content views that I'm publishing. And so what I'm going to do is I'm actually going to go out and I'm going to build these systems or install the applications on this. And this, from our perspective here, as the administrators, we're not really concerned about what's going on here. This is the responsibility of the developers. So you get the developers involved because this is a GitOps and DevOps kind of model. And the developers provide you with the Ansible playbooks to deploy their application. But they also provide you with the testing procedures that you need to test to ensure that your applications have been deployed properly. So in this one, what we're doing is we're building a all-in-one JBoss application, and then we're actually running create, read, update, delete against all of the interfaces on that JBoss application. We're also building out a LAMP stack and then running all the stored procedures against that LAMP stack to ensure that we're managing that appropriately. And the last one, because it wasn't, I needed something that wasn't a database, I said I'm going to build a WordPress server. And then in the test WordPress task, what we do is we deploy a WordPress site, deploy all the content, add some comments and et cetera, and update the content. And then we check it all to make sure that it's okay. If all of those tests come back successful, what we do is we run the same play that we ran previously, only now what we're going to do is take the content from the development environment, we're going to promote that to the QA environment. And if everything goes perfectly, we're going to delete the snaps. So let's just kick this off. Away we go.
Oh, is that all?
Yeah, is that all? That's all. So this is launching, and if we were to go to our satellite and go and take a look at the jobs that are going on, we can see, the tasks. We can see that we've got one running, and this is already off. And come on and update. Hello. Yeah, I'm over a slow pipe to my lab.
No worries.
Yeah. And what we see here is now the first thing it's doing is it's publishing the EPEL 8 content view. Okay. And it'll go on. And this actually takes a little time because we're deploying some rather large content views. We're deploying RHEL 8.10 in this instance. So there's a lot of stuff to get going. So we'll come back and check on this in a bit.
So, Mike, you were talking about the Red Hat infrastructure standard adoption model at the top of the show, and the demos that that Paul's walking us through is sort of the culmination of that dream. Why don't you walk us through what that model is?
Absolutely. So as Paul touched on, the original vision of the Red Hat Enterprise Linux SOE, or standard operating environment, came about roughly a decade ago, and it's been refined over time. But the main thing that's happened over the last 10 years is that it's still kind of remained a manual process. And so along comes Ansible into the Red Hat portfolio. And so now we can start realizing automation. I think the original 10 steps to an SOE was over 300 pages long. By embracing config as code, infrastructure as code, we can break that down to, code documentation of what the system should look like, run automation against it, and we can kind of bring those instructions down to more like 30 pages. And so that's where we kind of said, you take the Red Hat infrastructure standard, how do we want to embrace this standard operating environment to deploy RHEL at scale in a standardized manner? Well, we can use a lot of the tools that we have available, identity management, which will allow us to tie in to all of our RHEL systems and be able to manage users and groups and SE Linux rules and other types of policies across our Linux fleet. Satellite, which we've been talking about, and then Ansible automation platform, and tie everything together and have it all working together in unison. And so that's what the infrastructure standard is. And then we say the adoption model being this embracing of GitOps and automation and config and infra. And a lot of times people also are calling it config as code today and just not infrastructure as code. Because we're going beyond the infrastructure too in these models. We're actually configuring the applications and the workloads that are running on top of our RHEL deployments. So that's kind of the Red Hat infrastructure standard, which is our opinionated architecture of the entire solution working in unison. And then that adoption model, the GitOps framework and process that we are utilizing, like we just are seeing Paul run right now, to utilize Ansible for those GitOps-based pipelines in Ansible automation platform.
So this is all really, really cool. Like if there's people out there interested in implementing something like this in their environment, like how do people get started with this or move forward with using something like this in their own environment?
Well, we had some of our good friends at Microsoft come forward a little under a year ago and said, we're seeing a large uptick in the utilization of RHEL in our Azure cloud. And so we'd like to put together some best practices around running RHEL on Azure. And so we got together with an Azure team at Microsoft, and they introduced us to the Azure Cloud Adoption Framework, which is a set of guidance principles on how to efficiently and do things in a secure, well-governed, and compliant manner for deploying workloads onto Azure. The deploying of workloads on Azure, they use the term landing zones. So over the last 8 to 9 months, we've been working with the team at Azure to take those cloud adoption framework guidance principles for Azure and then marry those with these concepts that we are bringing to the table with the Red Hat infrastructure standard adoption model. And it wasn't just myself and Paul and Marty that worked on this. We had other chiefs here at the field CTO organization. We had cybersecurity experts within our Red Hat teams. We had technical writers. We had engineering leads. We had all types of Red Hatters put together this documentation, as well as having it vetted with some of our larger GSI partners to really give us, that second set of eyes to see how would you really integrate this with what we see with our customers. And so after, polishing, revising, et cetera, we published, I think, when was it? Back in July, Paul? We published the RHEL Azure Landing Zone Accelerator for Azure with Red Hat Enterprise Linux. So that document is just a set of guiding principles. It's high-level documentation, things to take into account to deploy your RHEL workloads in a well-guided manner, utilizing Azure best practices and Red Hat best practices. The automation, and I think that was, ultimately your question, Brian, the automation to do this. Well, on the heels of that, Microsoft was saying, we would like to see automation to do this. And so what we're doing is kind of taking this automation that we've been developing over the last year and sitting down with some Ansible experts to take these principles, these guidance, documents, and put that to code. And that's something that we're on the final steps now, I think, and we'll be probably releasing something like that to the public. They'll probably be on our Red Hat Community of Practice GitHub pages for anyone to take. We'll probably also do some accelerators on the Azure site itself as well.
So Paul, are we ready to jump back to anything in the demo?
You know what? Let's do that. We're going to jump back, and we're going to go to the other oven and kind of pull something out. So, because this is a rather long-running demonstration, you can see we're still publishing content, but I did some previous runs of this today. And so let's take a look. Oh, here's a previous one. Oh, crap. Demo gods. It failed, guys. Now, I got to ask a question. Is this a good thing or a bad thing that it failed?
Well, let me ask this. Are we in production?
No, we're not. We're in development.
Then I'd say it's a pretty darn good thing.
Celebrate failure.
Yes, we failed. Yay. So I actually contrived this to fail. So because you know what, it's if it all works out right to the end, we have nothing really to kind of talk about and explain why we did these sorts of things. So let's dig in and kind of find out why it failed and go along. And as an aside, I'm gonna mention this workflow that we're looking at is to an extent greatly simplified, because what we're not showing in here are the tasks that we would perform on failure. So normally on failure, we would have a second line coming out of most of these boxes, whereby what we're going to do is we're going to gather some information about the current task that we're on, and then we're going to do some notification. We're probably going to take a snapshot of the system as well, so that we know what was going on when it failed, and we can look at it again later. But let's zoom in on this and kind of go through where things were. And if we zoom in, we can see that looks like we were able to, deploy our content, promote it to dev, create the systems, and it looks like, well, our LAMP systems and WordPress system, they went through great, but our JBoss build blew up. Let's figure out what went on there. So if we can drill into this and take a look at the output, and give it a second, and we can go through the task and find out what happened. As we scroll down, we can see that it went, and it started to make sure we got the appropriate repos in place. And start looking at deploying the system. Oh, that looks good. Everything's fine. We get the stuff installed. We get our sample app. We go to build. Oh, it's saying, oh, you know what? This repo doesn't have Maven in it. So there's a problem with our publication that looks like the particular Maven file that we need to help deploy our application isn't in the content view. And so this particular task failed. So kind of back to the drawing board, we figured out where there is a problem, and now we can go and fix this and run it again. And if we had, we want to drive further along the automation route, we could write code to respond to particular failures.
That's a part of the benefit as well. A lot of the practices that we've introduced into the Red Hat infrastructure standard adoption model are based on practices within the open practice library. I invite our viewers today to visit the openpracticelibrary.com, check out the articles there. The one in particular that I mentioned was celebrating failure. And the notion there is to, instead of not talking about failure, to stay all hush hush. Don't talk about failures. We're always winning. We're always succeeding. By celebrating failure, you get your teams talking about failure modes and common patterns around issues and problems that arise in the deployment of our code base, so that these types of things can always be visible in front of mind as we're developing and deploying code. And as such, it's going to help us to be better at shifting these failures to the left and have them occur during dev, during QA, so that we're less likely to ever experience any of these failures once it comes time to promote and deploy to production.
All right. So is our build proceeding, Paul? Except now you're on mute.
Yes, it is. As I said, this takes a fair amount of time to walk through this particular workflow. We're still running. We're still publishing content.
So I know we're talking about this from an Azure perspective. So everything that we see is running on Azure, but that was just the beginning of this, wasn't it? We're expanding the platforms in which we can use these practices. Correct?
Yes, we are. So because we're actually the upstream project that we're working on. Mike mentioned that something that we should be able to publish in the not too distant future. We have an internal project called Project Showroom, and Project Showroom was originally designed to take the base code that Marty and myself and Mike wrote as part of our proof of concept, and turn that into production level code for deploying, in this instance, on Azure. The next step is to take that code and ensure it's properly segregated, so that we have a section of the code that basically does bootstrapping. And it will do the bootstrap, and whether we're using Terraform under the covers or we're using straight Ansible with the Ansible collections for the target cloud, it doesn't really matter. But once we're up and running with the bootstrap configuration, that would be typically our identity management and our satellite server. When we go and configure the satellite server, we're configuring the satellite with all of the compute resources that we need for any target. So it could be your satellite server could talk to VMware, it could talk to KVM, it could talk to OpenShift Vert, it could talk to OpenStack, AWS, Google. It doesn't matter. And now what we're trying to enable is that with this landing zone model, is it's easy for our customers to extend into a given cloud without having to change the processes in which they run their environment or deploy their environment. It becomes uniform. If you want to switch from this cloud provider to that cloud provider, you can build your bootstrap, run your bootstrap code to create your landing zone, and then run your deployment code to start deploying your workloads.
So one thing that I kind of geeked out about when we were prepping for this episode was the talk of pipelines. Before I came to Red Hat, I actually worked for GitLab for about a year, and so everything was about CI pipelines. Of course, that was largely from, say, the developer application level, but this is a beautiful merger of pipelines and CI and infrastructure. We talk about sysadmins and being worried about automating themselves out of a job, when in reality, somebody's got to build these automations. Somebody's got to prepare the different use cases. So, like Paul's example includes a Maven build. And we mentioned WordPress. What about? It seems like every other week there's a new development language out there. To be able to extend those builds to include things like new programming languages or new versions of existing, say, Python libraries. Someone's got to be there to manage those pipelines. All we're really doing is automating away a lot of the mundaneness of being a systems administrator, because otherwise you've got to build out every one of these servers by hand. You've got to install all the packages by hand. You've got to do all the configuration by hand. But what we're talking about is deploying enterprise scale applications on infrastructure that we just spun up using automation. I mean, this is really incredible when you think about everything that's going into just that. It's kind of that workflow.
Absolutely. And one of the things that's pertinent to what you're talking about, Eric, is if you remember, in one of the workflow components that Paul was showing, there was a step that deploys the build or the base image. And so what we're wanting to do is utilize satellites' inherent features of us being able to populate these base images that we're using Image Builder to build. You don't have to. People are talking about other tools in the chat, I believe. You can use Packer if you want. The main thing is we're using standardized builds configured and defined in Satellite, and then the same workflow can be utilized. All you have to do is supply a variable that says, let me see what deployment platform I'm on. I'm on Azure. I'm going to use the Azure build image. Or I'm on EC2, I'm going to use the EC2 build image. All of the automation is the same across the board. All of our content and packages is the same. Our testing framework is the same, et cetera, et cetera. The pipeline itself is the same. We're just changing a variable that points it to this target. And then now our systems are deploying the exact same on EC2 as they were on Azure. And so we could invite somebody to log into a system not knowing what they're logging into and just say, can you tell the difference in these two systems? The only way they could probably check is if they looked at proc and were looking at kernel parameters for the underlying hypervisor it's running on, or maybe a local agent if we're running some like cloud agent. But the key is standardized builds, standardized operating environments, and we're all doing it via automation.
This is all really, really exciting, super cool stuff. What's the best way people can keep track of what you're all working on and stay up to date on all this?
So it's really interesting. I was going to say kind of what's coming next, right? So Mike and I and Marty are going to try and take the stuff that we're doing around Project Showroom and build a community so that other people can join in the effort of helping us create this environment. We've got a number of engineers that have been working on this in the back end with us that are willing to also lend a hand. And some of the things that we're looking at doing is, as an example, I've got some sample code on my GitHub that actually does a deployment of Image Builder locally. And what it also does is say, okay, what I'm going to do is if I need to build a new image for Azure, it says, okay, go build me an image builder with this particular version. Once it's deployed, use this activation key to update it so that we can configure the repos on the image builder system, not the actual target server, but configure it so that image builder is getting all of its content from a satellite content view, and then build a image builder image for my target cloud and upload it to my target cloud. Then once that's committed to my cloud environment, register that image back to satellite so now I can build in new systems for it. We can also do that with Red Hat image mode. So as we start looking at saying, okay, I want to build an OS tree layered container that's bootable and deploy, I'm all capable of doing. So this is kind of the future of where we see this thing going. And like you were saying, is this going to get rid of somebody's job? Absolutely not, because as we start and looking at the future, where we're going to have increasing edge workloads, we're doing things, we're not going to have time to build anything bespoke, right? You can't build by hand and keep up with keeping the lights on. We have to do this automation in order to move forward, in order to evolve.
I think also we were planning to, well, let me mention this. So I think some of our viewers, if you've been doing Instruct Lab, you might think of Showroom, and now we're talking about Showroom. So the name will probably be different than Showroom. But and we were using Showroom before Instruct Lab at Summit. So, but we will do the good thing, and we'll change the name. But the main thing is it'll be on the Red Hat COP. We're going to be following up with our Azure partners at Microsoft to make sure that we're getting this work out on the Azure websites. It'll probably be a combination of all Ansible, some Bicep, probably some Terraform maybe, and Ansible. The key here, though, is that our Ansible config is reusable no matter what the infrastructure components that lay it down. And then we'll also be working with Marty to get a validated pattern out there. That would be another area for us, for our customers and those who want to work with us on the upstream on putting together a constantly repeatable deployment. That's another thing that's great about validated patterns here, is that in the past we would release a reference architecture, and the day we publish it is the last day it's relevant, because everything else is changing, to the future. You go back and look at that reference architecture a year later, nothing works because all the versions are changed. With Marty and the validated patterns team, working on putting out a consistently tested, consistently automated builds of our reference architectures, allows us to see problems as they exist. Again, we're shifting problems to the left with validated patterns, figuring out where problems occur before they occur at our customer sites. So I would invite our viewers to also be looking at the validated patterns site for more updates as they come.
And be on the lookout, because we're going to do the same thing for AWS and Google. They both have landing zone models that we're going to take advantage of.
Awesome. That's so cool. So Marty, any closing thoughts on your end?
Yeah, thanks. I think one of the things to sort of put a capstone on this is that if you're going to be doing exactly the same thing everywhere, you can create an image that is an exact duplicate of every other image. That isn't a terribly interesting thing. What makes these GitOps and infrastructure as code systems really interesting is that they have built into themselves the idea of dealing with the inherent variances that are going to occur between AWS and Azure and GCP and bare metal and OpenStack and wherever else you may deploy. It takes real work, to craft a solution that is able to operate in those environments. But the effort is frequently worth it because it gives your products the agility and discipline to be able to move from environment to environment. And it makes everything so much easier because the more standardization, the less you have to worry about, is this thing exactly the same? If Joe built it versus Mike, hey, Mike likes LVM, Joe doesn't like LVM. You wind up with those subtle differences between systems. There are a million decisions to make, when you're doing this sort of system build. And if you can have that level of standardization, those variables, those things that were variables, stop being variables anymore. And you can focus more on, the business problems and things that you'd probably rather be focused on.
Yeah, I love that. If you're worried about automation taking away your job, think about it this way: automate the boring stuff so you have more time to hang out with us on RHEL Presents or learn about Instruct Lab. There's just so much out there to learn. There's this concept. We've got 4 kids in the house, so this may be a fake news, but sleep is apparently a thing, or hobbies. So I don't see automation taking anyone's job away, just increasing chance to take PTO, to log out at the end of the day, to have higher levels of job satisfaction. There's just so much that can be done. And if you automate away things like setting up Maven repositories, you don't have to worry about it so much. Brian, any closing thoughts on your end, sir?
Yeah, I just want to say thanks so much to all 3 of you for joining us today. This was a really great demo, really exciting topic, and really looking forward to see what you come up with in the future with this.
Thanks for having us.
Yeah, absolutely. We'd love to come back once we have some more automation to demonstrate. I really want to get to a point where we can have something where I can have a multi-cloud deployment with IDM integrated across clouds, satellite and capsules across clouds, all working in harmony, and workloads deployed over here. And before the CEO can say we're switching clouds on his press conference, we're already doing it.
Yeah, that's great. I love that. I love that analogy. So that does bring us to the top of the hour, just about. And shockingly, we started on time. Actually, all 5 of us were already ahead of time, which never happens on this show. So, all in all, I'd say it was a good day. So I do have a bit of an announcement, but first I wanted to say thank you to Paul, to Mike, to Marty. Thank you, all 3 of you. We kind of put this together last minute. This was a really cool conversation. Probably one of the least flashy. Now, I say this in humor. It's probably one of the least flashy demos we've had in a long time, only because of how well it was put together. The pipeline, the tests, the built-in error checking. That's how change should be seen in an IT environment. It was so much. It was a non-event, really. To be able to stand up infrastructure, deploy a workload, to check it in dev, promote it to QA, and eventually to production. That's how IT operations should be. Not this staying up till 2 a.m. and being exhausted and tired and then starting a deployment by hand. this is how IT operations should be. So Paul, thank you so much for building the demo. Mike, thank you. Mike and Marty, thank you guys for collaborating. A lot of time and effort went in with these three gentlemen before we even got to this point to record. So thank you, all three of you. I really appreciate it. So stay tuned. If you're new to our channel, make sure to subscribe, hit the like button so we know that you enjoyed the content. So coming up, there'll be no Into the Terminal this week. Scott and Nate and team are traveling to an in-person meeting at the Red Hat Tower. I'll explain why I'm not there in just a moment. RHEL Presents is going to be on a bit of a break, but never fear, Brian Smith will be back. I, on the other hand, have a bit of news. I am not leaving Red Hat, so let me squash that real quick. But I am shifting to a different team. I am going to be working with our cloud partners. So it was kind of ironic that we had a cloud-focused episode today. But I'm going to be working with our CCSP team, which are cloud providers, hyperscalers, as a technical marketing manager. So I'm going to actually be vacating my seat with the RHEL team. Yeah. It was bittersweet, definitely a difficult decision. Leaving the show and our live stream community, definitely not something I took lightly. But I'm not going far. I'm actually going to be working at the portfolio level, working with our partners. So if you're doing any work with AWS or any of our CCSP partners, I'll probably be around to make some content about it. So. Brian has told me he plans on continuing the show. We're going to be hiring a backfill from my position, or maybe we can grab Nate or somebody to come in. But RHEL Presents will continue. Just not sure exactly when the next episode will be. I know we've got guests lined up for the RHEL 10 beta. We're talking about high availability, so HA. Lots of topics for both Into the Terminal and RHEL Presents, so that'll all continue. So I'm really excited to have been a part of this show. This is episode 83, so 80 minus 20, so over 60 episodes. My goodness, 60 episodes, because it was like episode 18 or so when I came on the show for the first time as a guest. So over 60 episodes of RHEL Presents. I helped kick off Into the Terminal and was a host there for over 40 episodes. My goodness, it's been a long and crazy 3 years, but coming up on 5 years with Red Hat. Really excited to be staying in the family, but moving to a slightly different role. So Brian, thank you so much for being my co-host. You were my first choice after I saw your RHEL 8 videos, RHEL 8 beta videos actually. So that's how far back, and now we're talking about RHEL 10 beta. It's craziness, just how fast the time has gone and how much has changed around the RHEL business unit.
Yep, yeah, and thanks, Eric, for all your hard work with everything, and we all wish you the best in your
appreciate
position.
It. That hit a little bit harder than I thought. Telling my team was one thing, but okay. I'm not going far. Like I said, grab the Discord link there in the top left hand of your screen, or check the show notes for all the links you saw today. As I said, no more live streams this week, but Into the Terminal will be back next Friday, talking more about compliance. We're going to bring back JSCAR and Nate. I'll be producing that episode as sort of a farewell. So definitely check back in next Friday. And until then, catch all the content we have on the RHEL YouTube channel. There's back episodes of this show and Into the Terminal, and we've got tech tip videos, self-paced labs, all sorts of things to keep you occupied during the interim. So on behalf of our guests, Mike, Marty, and Paul, my co-host Brian, and the entire Red Hat Enterprise Linux team, thank you all so much for joining us, and we will see you next time.